Hi guys, and welcome to another lesson. Today we're going to find the surface area of a cylinder. And the surface area is just the total area of all of the sides of a cylinder. So let's go ahead and get started. So the first thing we need to know is, what is a cylinder? So a cylinder is a three-dimensional object with the top and bottom as circular figures, actually congruent circular figures, and then a curved side around. So think about a soup can or a paper towel roll, something like that. So a cylinder, when flattened out into a net, or on, like if we flattened it out on the table, would look like two congruent circles connected by a rectangle. So this rectangle would stretch around that cylinder. So how do we find the surface area? Well, I think the net figure, or the two-dimensional flattened version of a cylinder, is the easiest way to think about finding that total area. So the first thing we need to do is we need to find the area of both of those circular bases, and then we need to find the area of that curved side, or that rectangle that connects those two bases. So we've got to use a little bit of circle knowledge in order to be able to use this formula. So here I have my net, my flattened figure, my flattened cylinder, and the first thing we need to do is find the area of those two circular bases. So to find the area of a circle, it's pi times the radius squared. And we use this formula a lot in our last video on finding the volume. So we're going to first find the area of both of those circles. So in our equation, that's the 2 times pi times radius squared, because we're finding the area of one circle and then multiplying it times 2 to add together both of those areas. The next part is finding the area of that curved side. So there's a couple parts that we need to understand. And the first is that one side of this rectangle is actually the height of the cylinder. So to find the area of a rectangle, we would normally multiply the length times the width. But on a cylinder, that width is actually the height, or how tall that cylinder is. And then the length is actually the circumference of the circle, because when I take this rectangle and I wrap it all the way around the cylinder, that's that distance around the circular base. So for our length, we're going to use 2 times pi times the radius, and that is our formula for the circumference of a circle. I have a video on the parts of a circle that will walk you through finding the circumference if that's something that you're struggling with. But so we need to find the area of both of these circles and then of that rectangle, and then add them together. So to find this rectangle in the center, we're going to first find the circumference, and then we're going to multiply that times the height. So we've got this really long formula. So let's go ahead and break it down in an example problem. All right, so before we get started, let's go ahead and grab that formula. We're going to find the area of both circular bases and then the area of the curved side, and we're going to add those two areas together. So here's my cylinder. I have a height of 12 centimeters and a radius of 5 centimeters. So the first thing I always like to do is I like to rewrite my formula on my paper. So I've got this really long formula, and then I replace the parts that I know. So everywhere there was an R for radius in that formula, I replaced it with 5, because 5 is the radius of this cylinder. And everywhere I saw an H, I replaced it with 12. You could also take this a step further and replace all of the pi signs, or the pi symbols, for 3 and 1400ths. For our purpose today, instead of using the pi button on the calculator, we're going to use an approximation for pi, which is 3 and 1400ths. So you could also go ahead and replace every pi with 3 and 1400ths. So now that I have an equation I can actually work with, I need to remember to follow order of operations to get my answer here. So the first thing we always do in order of operations, if we don't have parentheses, is to do the exponent. So I'm going to first square 5, and I will end up with 25. Now from here, I can't add together anything until I do all of my multiplication. So I'm going to go ahead and use my 25 and I'm going to multiply it times 2. And I'm also going to come over and let me grab my pointer. I'm also going to do this calculation here. I'm going to multiply 5 times 2, and that's going to give me this 10. So now I've kind of simplified my problem down even more. And then the next thing I'm going to do is multiply times pi. So I'm going to go ahead and multiply 50 times pi and 10 times pi. And I can't add yet. So I still have one more multiplication problem to do, and that's right here. I've got to multiply 31 and 4/10 times 12 before I can add. And then I'm going to add both of these together. So this right here, this 157, this is the area of both circular bases added together. And this 376 and 8/10 is the area of that rectangle that wraps around the side of the cylinder. So we found the area of both circular bases, and then we found the area of the curved side. And now to find that total surface area, we're going to add them together. And we end up with 533 and 8/10 square centimeters. For area, we measure in square centimeters because we're looking to see how many square units will fit around the outside of this figure. So maybe we want to wrap a cylinder as a gift. Maybe we have a canister and we want to wrap a label around it. These would all be situations where we would want to find that surface area. Let's try one more example. All right, so we're going to start by bringing down that formula. We want to find the area of the two circular bases and then add that to the curved side. So here is our new cylinder. And this time, instead of having the radius, I have the diameter. So I've got to do an extra step. The diameter is that whole distance across that circle. So from one side of the circle through the center to the other side of the circle. But all of our surface area formula uses radius. So we've got to do an extra step here, and we've got to divide that diameter by 2 to find the radius. 2 radius equal 1 diameter. So I'm going to take my 16 and I'm going to divide it by 2 to get 8. So for our purposes and our equation, we're not going to use that 16, we're going to use 8 for the radius. So let's bring down our formula and replace the information that we know. Everywhere I saw an R, I replaced R for radius with 8 because that's what we found. And then I replaced the H with 35. And now I have an equation I can work with. So we're going to follow order of operations and we're going to square 8 first. So 8 times 8, which is going to give us 64. And then this step, I like to shortcut a little bit because we're doubling. So I double 64 first, and then I double 8. So for this next step, we're going to do 2 times 64, which gives us 128. And then we're going to do 2 times 8, which gives us 16. And now I'm left with technically 3 equations. I've got pi times 128, pi times 16, times 35, and then I'm going to add those together. So for pi, we're using 3 and 1400ths. So when I multiply pi times 128 and pi times 16, this is what I end up with, 401 and 9200ths. And then I multiply 16 times pi and get 50 and 2400ths. Not ready to add yet. We have to finish out multiplying. So we're going to multiply that height, which was 35, and we end up with 1,758 and 4/10. And now we can add those together. So we have the area of our circular bases right here added together, both circles, and then we have our area of our curved side right here. And we're going to add those together, and we end up with a surface area of 2,160 and 3200ths square inches. All right, and now I've got a couple for you to try. These are very long formulas, so I do encourage you to pause the video and write down the formulas before you get started so you can replace that information. But if you get stuck, as always, I'm going to walk you through it at the end. All right, so here's your first now you try it problem. We have a cylinder with a radius of 8 centimeters and a height of 20 centimeters. Go ahead and pause the video and try to find the surface area of this cylinder for yourself. All right, hopefully you paused the video. So here we go. We are going to bring down our surface area formula and we're going to replace the information that we know. So everywhere I saw an R for radius, I replaced that with 8 because that was the information given. And everywhere I saw an H, I replaced it with 20. And now I'm going to go ahead and walk through simplifying the problem. All right, so you should have ended up with a surface area of 1,406 and 72 hundredths square centimeters. Let's try one more. All right, guys, so here's our last problem for today. Let's go ahead and grab our formula. For the fourth time, we want to find the area of both circular bases and then find the area of the curved rectangular side that wraps around them. So we have this very long formula. Here is your cylinder. Notice we do not have the radius, we have the diameter. So you've got to do an extra step before you get started. So go ahead and pause the video and try to find the surface area of this cylinder. Okay, hopefully you paused the video. Here we go. So we're going to bring down our surface area formula, and everywhere we see R, we're not going to put 20, we're going to put 10 because the radius is half of the diameter. So I've replaced all of my radius or my radii with 10, and then I've replaced my height with 45. So let's go ahead and walk through the rest of the problem. And there we have it, a surface area of 3,454 square inches. So again, we're using 3 and 14 hundredths. So if when you solve this, you use the pi function on your calculator, you're gonna have a slightly different answer. It's probably gonna be a little bit larger than what we have here. And that is it for today's lesson on finding the surface area of a cylinder. It is a very long formula with a lot involved, so our biggest takeaway should be whenever we're doing any formula type problems is that you have to follow order of operations. And we need to remember our algebra knowledge of substitution and make sure we're substituting in the right numbers for all of those variables that are given in the equation. That's it for today's video, guys, and I'll see you in the next one.